Hello everyone. In this video, we will learn about the propositional logic. Propositional logic consists of simple and compound sentences. A simple sentence or an atomic sentence has a single propositional symbol. We could use some symbols to represent. For example, this is a sentence, it is raining, and we use P to denote it. The sky is blue, we use Q to denote it. A proposition can be true or false. In case if it is actually raining, P will be true. Here Q is false if the sky is cloudy. In case if we have compound sentences, we can use logical operators to connect them. In case if it is not raining, the sentence will be represented as negation P. And if we want to connect the two sentences, we will use conjunction. P conjunction Q will be it is raining and the sky is blue. So this is how it is represented. Syntax of propositional logic. It defines the allowable sentences in propositional logic. We use symbols to represent the assertions. The logical operators includes the negation, conjunction, disjunction, implication, biconditional. As far as the precedence order is concerned, the rule followed for precedence is highest from the lowest. So that is from this operator to this operator. Semantics in propositional logic. It defines truth values of sentences. It's a model determines the truth value of propositions. With n symbols, the number of models is 2 to the power n. Truth tables help to evaluate the compound expressions. P and Q are the propositions. Here negation of P, it specifies when P is true, it will be false. If it is false, this will be true. So here P is false in these two cases, negation of P is true. P is true here, negation of P is false. P conjunction Q, both P and Q should be true, only then this P and Q will be true. So here in this case P and Q are true, here P conjunction Q is true. P disjunction Q, P or Q, here either P or Q should be true. So here in these three cases, here Q is true, P is true, P and Q are true. P disjunction Q will be true in these three cases. P implication Q, P implies Q. If P, then Q. So this leads to true when either P is false or Q is true. So we could see P is false, Q is true here. But here it's not satisfied. Here Q is true. So in this case, P implies Q will be true in 1, 2 and 4. The same way Q implies P. If Q, then P. So either Q should be false or P should be true. This is bidirectional. This is true if and only if P and Q are the same. So P and Q are false, this is true. Here P and Q are true, this is true. Building a knowledge base. There are two steps. The first step is to define the propositions for a scenario. Step 2 is to use the rules based on the logical operators. We shall consider the Wampusful problem here. I, J is going to represent the room. P is going to represent the pit and B is going to represent the breeze. The first rule is negation of P, which means in the location 1, 1 there is no pit. Rule 2, a breeze in 1, 1, it's a bidirectional implication. It's a pit 1, 2, disjunction pit 2, 1. So it's a bidirectional implication, which means both should be the same. So here representation of a pit in this location, representation of a pit in this particular location, so which implies If there is a bit in either of the two locations, 1 comma 2 or 2 comma 1, there will be breeze at 1 comma 1. That is the representation. This is how we will build the knowledge base. Inference in propositional logic. The inference is to determine new facts from the existing knowledge. It uses enumeration and model checking. This is the truth table representing the values of the propositions and the rules and the knowledge base. Key logical concepts. We'll start with tautology. This is true in all models. Example, P disjunction negation P. So whatever may be the value of P, the expression will be true always. Contradiction, it is always false. So whatever may be the value of P taken, the expression will lead to false. So P conjunction negation of P, if this is going to be 1, this will make it as 0. So 1 and 0 will be 0. If this is 0, it will make it as 1. Negation will make it as 1. 0, 1 again will be 0. Then satisfiability is true in at least one model. To make the expression true, so either P or Q should be true. Refutation, it's a method which is used in logic and AI to disprove a statement by demonstrating a contradiction with the known facts. For example, so someone is claiming all mammals live on land. To refute this claim, you can provide a counterexample like whales or mammals. Whales live in water. So since whales are mammals but do not live on land, we can disprove the claim all mammals live on land. This is refutation. Reasoning patterns in propositional logic. Modus ponens. If alpha implies beta and alpha is true, then beta is true. For example, if it rains, the ground will be wet. So rain implies a wet ground. So this is alpha, this is beta. It is raining. Rain is true. This alpha is true. So which means alpha implies beta and we say alpha is true, which means then beta is also true. So the ground is wet ground is true. So this is modus ponens rule and elimination. So if alpha 1 and alpha 2 and alpha 3 is true, we can infer any individual as alpha as true. That is, suppose we have a statement, it is sunny and warm. And using and elimination, we can infer two separate statements. It is sunny, it is warm. This is and elimination. Resolution rule. This resolution rule is a fundamental inference rule which is used in propositional logic and first order logic. The resolution rule states if we have two clauses, one containing a literal and another containing its negation, we can infer a new clause by removing both P and its negation. We can combine the remaining parts. We shall see one example. We have two statements here. P disjunction Q, P R Q. P is it is sunny, Q is I have an umbrella. Negation of Q is I don't have an umbrella. So there are two statements. As per the resolution rule, we can remove a literal and its negation. After removing, we can combine the remaining parts. So from these two statements, we are identifying the complementary literals, say Q and negation of Q. We can combine the remaining parts. So which means the result would be it is sunny. So this is the conclusion that we have derived. We have seen the resolution rule. Before applying the resolution rule, we must convert the statements into conjunctive normal form, CNF. The first step is we are eliminating the biconditionals. For example, P bidirectional implication Q, it will become an expression like this. We are eliminating the bidirectional implication, the biconditionals. And number two is we are eliminating the implications also. So after which the implications will become a statement like this. And number three, we apply De Morgan's theorems. So this expression will get changed like this. The fourth step is we are converting it to disjunctive classes. So all the classes will get changed to disjunctive classes like this. So in this way, these steps are ensuring that the logic is in CNF form, which is so easier to apply the resolution for inference. Forward and backward chaining. Forward chaining, we start with the known facts and we are adding the conclusions. We use data-driven approach. For example, in a medical diagnosis system, we start with the symptoms basically. We have fever, cough. So the system applies rules to infer the possible disease and it updates the diagnosis as more symptoms or test results are added to it. Whereas in the backward chaining, we'll start with a goal and we'll infer the required facts. We use a goal driven approach. In backward chaining, the system starts with some suspected disease like pneumonia and it is checking if the necessary symptoms are present. If some symptoms are missing, it asks for some more tests or details before confirming the diagnosis. This is all about the propositional logic. Thank you.